So hi all and welcome to our series about SSI applications. My name is David from IOP and I will guide you today through the first episode. The first episode, we're going to discuss the cryptographic Keyvault, which is a tool to manage and secure your digital wallet. Think of this digital wallet as the equivalent of your physical wallet, but in a digital world. So it has digital funds, keys, identities, and so on and so forth. Here on this slide, you can see the IOP technology stack. At the base of it, you find a cryptographic key vault. So you can already see that it is a very important part of our SDK. As you can see, the cryptographic key vault can be used to access this digital wallet, generate personas, so generate identities for yourself, sign statements proving that you own a specific identity, and so on and so forth. So the key vault contains these key pairs that manage your access to funds and assets on the blockchain. These assets could also be identities, but it could also be something else. For me, it helps to think about this key vault as a very large, secure safe that contains a lot of keys. Actually, it contains enough keys for a person if the person uses each second a new key for the whole lifetime of the universe. Whenever I talk about a key pair, I speak about a public key and a private key. The public key and the private key are bound together to each other by a hidden mathematical relationship. This means that given the public key, it is impossible to find the private key. So the public key allows others to verify your identity, while the private key is used by you to prove that you own the identity or a public key. This means that the public key can and also should ideally be shared with whomever you want. The private key, however, should be kept very securely at your side. Since you can have a lot of key pairs, this means that you can have a separate key for your email identity, your social media identity, and your digital currencies, so that these do not get mixed up. Typically, when we use a key vault, we need to generate one first. And this consists of two steps. The first one is to generate a seed, and the second one is to create individual keys from this master seed, which is also called a master secret. Keep in mind that one key vault belongs to one entity. So this entity could be a device, a person, but could also be a company. Depending on who this entity is, you need to secure the key vault appropriately. So now we're going to discuss the first phase. Bear with me, this is going to be technical, but after it, we will go to the hands-on session and then everything will fall in place. So the first phase is to generate a seed. And in order to have interoperability between different wallets that implement our technology, we also follow a specific standard. This standard is called the Bitcoin Improvement Proposal, or shorthand for BIP. I will often refer to these as just BIPs. So on this slide, we will see the BIP 39. The first step in generating a seed consists of generating a random key phrase, also called a mnemonic. On the screen, you can see such a sentence, and this sentence consists of 12 words picked from a specific dictionary. Actually, the way this works is that you generate random numbers and you translate them using this dictionary to the words you see on the screen. So these dictionaries are defined for several languages, but we will stick with the English one. The next step is that you add an optional word. This actually has two really cool features. The first feature is that you have an improvement in security, since knowing the mnemonic only does not give you access to your funds and/or assets. Secondly, you also have something which is called plausible deniability. So since this word can be optional, it could be anything, and it would still resolve to a valid vault. What you could do now is create two vaults. a fake vault and a real vault. And once they ask you to give you your vault, you just give them your mnemonic and the fake optional word. Now this will resolve to a valid vault and they will see what is in it. But if you have fake identities and just a small amount of digital currencies in it, they could be tricked and then you would still keep your real vault. So there is no way of knowing which optional word belongs to which mnemonic. The third step is to feed the key phrase and the salt or this optional word into the key stretching function. This key stretching function is actually a secure hashing algorithm and produces a 512-bit output. This output is your master seed. You can see that by the large number of bits that is included here, that it becomes really difficult, actually it becomes infeasible to find somebody's vault by accident. Actually, if you want to have a fun afternoon, just try to calculate this. Trust me, the chances of finding a valid vault are equal to winning the lottery every day of the year. Actually, the chances of finding a valid vault are way slimmer. The fourth step is that you take this seed and you encrypt it with a secret key. This is important because now you can store your seed on your local device without fear that somebody hacks into your computer and decrypts it, since you are the only one who knows the encryption or decryption key. Think of this as a password. The second phase is to generate individual keys, and this goes according to the BIP32 standard. So what happens is that you first take the decrypted seed and feed it into a hash function. Now it splits it into two equal parts. On one side, you have the master private key, and on the other side, you have the chain code. The master private key has a corresponding master public key. Remember, this relationship is hidden. So if you have the public key, you cannot derive the master private key. Think of this as a one-way function similar to hashing algorithms. It becomes very interesting if you also take this master private key together with a chain code and feed it in a hash function as well. For this, there is an index that you can change, and this will result in a child private key and a child chain code with the same properties as their parents. The child private key has also a child public key attached to it. By changing this index I, you can create a lot of children, and this results in a very big family. What is even more interesting is that you can take this child private key and the child chain code and again execute a hash function. Now you can get an even bigger family. This is called a hierarchical deterministic structure. And as you can see on the picture, it follows a tree-like structure. It is very flexible in nature and it offers a lot of features. You can imagine use cases where, for example, a company owns the seed, but each of the different departments are represented by children, and each employee has a grandchild key tied to it. Now, in a practical session, we will use these concepts and work with them. And in the first session, we will actually create and load a vault. If you're interested in finding more about this hands-on session, then just click on the following link and don't forget to subscribe to our channel.